Hello, hello, and welcome to the next part of today's stream. Uh, so yeah, I'm messing around with the circular buffer stuff here. And I want to add a gap retail. Since that will probably make things easier. So whenever we remove stuff, we will run the what do you call it? The actual yeah, right now it's not working whenever the objects are created all one by one, but this works. Yeah, this works. Also, you could optimize it by creating the same sizes of arrays for these two pieces here. Because then you would only want one write head and read head. At least. You could. Anyway. So we do have our processing here. Well, this works. I'm not sure it works when... Well, it does seem to work no matter what right now. Yeah. So what we should do is actually when we remove an item, also when we try to render, let's zoom in here. Let's remove all of this. We don't need it. Okay. Of course, we do it for every item. So what we should do here is of course offset into our tail. So let's do a const unsigned int index here, usigned, unsigned. Which is our segment dot gap retail plus I wrapped around a segment dot gap count, or not gap count, gaps dot size. So this should be fine. Okay, and then let's start removing some stuff. So whenever we click, this only needs to be done during debug mode, since we're just advancing the tail counter. Let's see, segments. Retail. Okay. Okay. Segment item retail equals the same, just with our item buffer. And I think that segment gap and we of course move the right head whenever we write, and whenever we delete, we remove the tail head. Alright, let's try that. Whoops. Let's actually add the debug. Segment gap right head. Okay. So we have our values here. Well, it doesn't work. It doesn't work. Let's see, the right head is of course it's the read head here. All right. And we immediately swap that. But yeah, it doesn't update anymore, at least not correctly. And that's of course because whenever we update this stuff, and plus segment retail. Let's see. Do we actually? Okay, let's add one more. And let's remove this one. And we immediately work again. But of course, we're not actually iterating the correct way. Yeah, this is buggy. Yeah, it doesn't work correctly at the end of the array. I'll fix it. Yeah, it's probably this code here. Yeah, let's see. Yeah, this is the wrapping. Needs to wrap. Segment. Gaps. That size here. I'm not sure it works, but let's see. 3. And suddenly it works. Okay, great stuff. And let's see, in debug mode, we don't have any stupid overflows somewhere. Or rather, bounce problems. Great stuff. Seems like it's working. Okay. We're wrapping away. We're wrapping away. So our rendering is the one that is actually kind of like off here. And or is it maybe it's because oh yeah, okay. So whenever we actually remove an item, we need to set the entry gap, of course. Yeah, maybe that's the problem. Okay. It's probably that we don't set the entry gap. Or rather exit gap. Let's see. Because the exit gap, entry gap, exit gap here. If the segment item count else total length, that's outside. Okay. Okay. Debug stats here. Segment exit gap equals total length. So if I remove the only item, we should see this coming into effect. Exit gap. There we go. And the gap index ends up. If otherwise we don't do anything. And if we add this to the exit gap at least. And if this this is messy. Okay, else do nothing. Otherwise it just stays the same. Right now this is not very pretty, but we'll see. There we go. We can actually add and remove stuff. Great stuff. That's awesome, man. And since we already have our add logic up here in our application. We already know how to add objects, so that's basically it. Okay, let's see, we should be able to okay. Let's see, else if so right now nothing will happen if we remove one. Okay, and let's see, we shouldn't get any overflows. Hopefully, at least. And right now we can't add too many. Perfect. Um, okay. That should be it, right? We have our stuff here. Okay. So that's basically it. We have running stuff, as they say. And the way we actually throw an object from one thing to another is by consuming these things. Okay, I'm just contemplating what to do in terms of implementing this stuff in combination with this. So it should be something like this stuff disappearing into this one. Okay. Let's see. So whenever we set up our game, we want one of these iron processors here as well. So we have our do test set up, blah, blah, blah. And let's do const int xpos const int y cpos. There we go. Let's rename this. Okay. And the last piece. Xpos end equals xpos start plus 2 cpos end plus 3. Okay. Do we actually store it? No, it's the start position. Whenever we create this, we don't set the belt segment index. I was also considering whether the tiles themselves should have a belt segment index. Maybe they should. So our tile data could have something like a belt seg where we do something like that. So let's see, whenever we do this test stuff here, update tile data, usually we do maybe it's just a building and a type index. Maybe we don't need it. Maybe we do have enough values for this. So yeah, so we store it on the type index. And then the subindex is the belt segment, I think. Yeah. Okay. Huh. Maybe we want another version of this where the instead of span it should just be data maybe. X data, C data. Maybe. Uh, what's the function? Okay. It's a local method. Okay. Because if we pass in the X data and C data here as our final offsets, we need the pass anyway. I don't like it. Okay, let's just call this several times for each tile, I guess, at least for now. Okay, let's calculate the tile index here. Plus this times this. There we go. Okay, let's do update tile data. Export start. cpos start 0, 0. Building type conveyor belt with the subindex of 0. +1, +2. +2, +1. +2, +2, and +2, +3. Okay. This should create our tile data here. And then we want to call let's do build a system, do test setup, blah blah blah. What's the, did I put it on the class itself? Yeah, I actually did. Where do I actually create the, oh, I don't. Oh, yeah, okay. So we want some different drawing stuff, I think, for the build segments. So we don't want to do it through the original pathway of creating a building. And right now it's hard-coded. Yeah. Yeah, we definitely want some kind of tool for this. But now we update the stuff there. Okay. We handle the drawing itself. Let's see. So in the build tool UI, we call this let's just call this in the application. And the CPOS end here, +1. And let's see, buildings, building type, iron processor. And what, build a system. And this should create a iron extractor, yeah. Okay, so then we want this build logic here to actually check if there's a belt somewhere. Let's see, create. No, that's not it. Create and get building summary. Um, yeah, so we allocate the resources. This doesn't actually have the Whenever we create the building, then create a building here. Uh, do we want to do the checking outside? Okay. Let's see. Let's create. And let's do this, and then let's try doing this. So if I do like this, okay. Let's see, and what's our texture indices? Blue 9. Funny. Yeah, now it knows that there's a building here. That's great. Um, yeah, let's add this later on. Anyway, right now we do that, but I want to send some information. Okay, we need some kind of logic where it will, whenever it gets created, so whenever we call this, we should do some kind of check if we're surrounded by potential belts, and we should kind of like add that uh, thingy to it. So whenever we create our building here, Maybe we want to do a check. Yeah, the building type is 0. So we could do another defaulted parameter. Yeah. Let's see, maybe something like let's do a building type here. Look for type. Well, this is certainly problematic. Maybe we just want the int here. Okay. Let's do that. Whoops. So we're fine. Okay, if we're actually trying to invoke a look for, let's do building type iron, not iron processor, building type conveyor belt. Okay, so inside this call, rendering related. Maybe even separate this. Okay. Okay, let's do something like a function that checks for a certain object. I'm not sure it's supposed to be this way. Check for building type. And let's do a int here. Const unsigned int xpos. Const unsigned int cpos. And then a const building type here. Return -1. If xpos cpos check look for type larger than or equals 0. Yeah, we will do some stuff. Right now we don't need this. Okay, let's do a switch statement here. Building type. Let's see, default. Return -1. Case, building type, conveyor belt. Let's see. Return -1 right now. If type index on this equals building type, return this building index. But I guess we would want some kind of like logic where we're actually, for one, checking around the building itself. So maybe we also want building type here, and then another one. Look for type here. This is also supposed to be const. I can't do that, I guess. Here's building ion processor. Ion processor here. And let's see, look for type here. Check the chunks, or rather tiles, around the processor. Let's do we can do it. Temp pause here. Temp expos. Temp cpos. Or rather cpos here. Okay. If temp expos larger than or equals 0. And we shouldn't be allowed to actually submit any values that are out of bounds. So we don't need to check other than this. If it is, let's set the tile index here. Well, we want to be able to return a more complex data structure. Let's do a struct here. Building add pos. Let's just do an int subindex, an int subindex, an int xpos, int cpos, and let's do a operator bool operator. Is that the correct syntax? I can't remember. Overload bool operator. Yeah, okay. Const. If and xpos let's just do return this. Okay, so we will return one of these structs here. There we go. So we can check if it's true whenever we return it. Let's see. And then return this, but and our first parameter is the type. The second one is the building. Then we are at temp xpos temp cpos here. Okay. Let's set the temp expos to expos +1. If this is lower than the stuff here. Let's do that, and then let's do CPOS here. Yeah, this is probably something I want to change eventually, but as a start, let's do this. Yeah. And let's do GXE, core print, found building, do order, conveyor, dude. Found conveyor, dude. Okay. So it actually happens. But, check data. Let's do at. See. Okay, this should output our stuff. 510, is that correct? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's correct. And 5, 0, 1, 2, 3, 4, 5, yeah, that's actually correct. Yeah, this should be more sophisticated since it should actually do a check here where we actually cache this value here. Check if it's the end of the belt. I guess we could do that just for good fun. Okay. Bool is check is end of belt segment. I guess we want a const unsigned int index. And let's see, G building data star. Conveyor belt segments index here. whoops, ref equals this. Return false. Okay, let's check if it's the last part then. Of course, we also want an XPOS and CPOS here for each belt segment. Let's see, belt piece, const belt piece reference. Piece inside the ref dot belt pieces here. Let's do int x res int c res. Let's just do 0. No, let's not do 0. Let's do the xPOS start ref cPOS start here. And then we want to xres plus equals piece dot x offset, and let's do the same thing for the c offset. Return whether xPOS equals unsigned int. This should be an int actually, so no problem. Xres and cPOS. Okay. So we accumulate the values. And let's do a const here, unsigned int, belt seg index. And let's do if check is end of belt segment, temp xPOS, temp cPOS, belt seg index, yeah. Alright, let's do this instead. There we go. Let's see if this still works. Something goes wrong at least, because it doesn't find it anymore. Am I doing this wrong? Okay, let's step into this. Thank you, buddy. Thanks for the support. Okay, so oh yeah. Uh, okay. Let's see. If I do this, where do I end up? Yeah, doesn't work that way. This doesn't work. Maybe we just want to. Um, so we could do something like a delta X, delta C here. So maybe we don't want this. So we could do uh, X n pos set n pos. Let's do delta X, or rather last X offset. Maybe we just want, no, 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 no. No, no, no. We don't want this. We don't want this. Let's see, return whether the X ref dot X start pos plus. Alright, let's create this in a more const conveyor belt segment belt piece belt ref dot. Okay, so we grab the last belt piece here. It should at least have one, otherwise we're yeah, assert. There we go. Let's do some assertions here. Last belt. Last belt plus X offset. C pos, C offset, of course. This should make more sense. Okay. Whoops. Okay. Found conveyor. And if we try building a building here, let's just do let's do GXE call print ran check. So that we can test it with some other iron extractors. Okay. We ran the check, but we didn't find a conveyor belt. So that's great. Okay, but we did here. We found an end of a conveyor belt here. And this is way faster as well. I mean, I guess we could calculate this outside, but well, no sense in saving that data, I think. At least now, good way to do it. Okay. Let's do void handle building coupling const reference what target let's do const building type and const unsigned int subindex. And let's do another switch here with this case as well. Break default break. There we go. I'm missing something. Yeah, I'm missing the last bracket here. Okay, so we want to couple our building with our thingy. And let's do check data here. And let's do building type. And let's do subindex here. Yeah. So we want to couple our data. This is check whether we have a certain building type. Let's do the okay, so if we want to handle our coupling, we'll do that. I'm contemplating whether this overall structure here is great or not, but we'll refactor it if need be. Okay. So I guess our buildings here, iron processor, would want a belt, kind of like thingy. Storage. Let's see. So it has state, it has accumulator, it has, well, it doesn't have any coupling. Hello, how you doing? I'm pretty good. I'm pretty good. How about you? I'm building this game here. So right now I want to couple this conveyor belt with this building here so it can eat the items on the belt. So right now I have this built-in logic recognizing that it's at the end of a conveyor belt when it gets built. So I'm contemplating how to store the coupling. I guess I would want to just create an empty coupling since it's probably going to have one. So maybe if I do iron processor belt coupling belt subindex belt segment index, and let's do an array of those. Iron processor belt coupling here, iron processor belt coupling, and then whenever I create the actual item, I also want iron belt coupling here. And I guess I want to not do this anymore. I'll just create empty fields here. I guess I should try to move away from -1 being the initialized state, but yeah. Okay, so this should. Thank you very much, and thanks for dropping by. Take care. Okay, let's see. So let's see. G build M iron processor belt coupling. Subindex here. Dot equals target dot subindex here. Okay. So this should handle the coupling. I'm not sure I'm going to do it like that, but at least it should work. Okay. And right now this building doesn't do anything because it doesn't have a store. Okay. Let's see. Let us allow it to actually swallow whatever is on the end of the thingy. So during updates, we will do let's do a for loop here. That is basically this. And iron belt coupling. Iron belt coupling. Let's do a very simple approach here. Should not be done like this in the end. So if the ref thingy here is above this, let's do a const. No, not const. Conveyor belt segment ref, belt ref, conveyor belt segments, ref dot belt index here. Belt ref. And then let's do segment instead, because then we can just plug and play this. And we of course want the total length as well. Okay, so this should allow us to consume whatever and again, this is not actually supposed to be storage data. And let's do storage data, storage. Should I grab the recipe as well? Recipe inputs. Let's just do it like this. Okay. This is more like a proof of concept, right? And it eats it. Oh, we have a bug. Oh. What's the recipe? Is it 10 or? Yeah, it's 10. Okay. We have a few bugs here and there. Yeah, definitely. So whenever it eats it, yeah, it looks a bit funny, but at least it uh, seems to be running sometimes, or rather not sometimes, but most of the time. Okay, but this coupling here now works. Yeah, it's like fast forwarding. So okay, overall it works. We just have a few bugs. Okay, we could try adjusting the recipe settings. Yeah, so maybe we just want 5 and then we split off some. Yeah, here. Okay, let's see. Yeah, it's basically allowed to actually accumulate a bit here. Yeah, great stuff. Great stuff. Great stuff, man. So most of our stuff works now. The belts are moving the objects. They are able to consume them. We only have a few bugs. For instance, that weird fast forward thingy. So it's probably whenever we remove an item, this logic here is not 100% correct. Um, Probably we would want to, yeah, so the problem is arising whenever the objects have, what do you call it? Um, Different size gaps, I think. Yeah, and then maybe we also want to decrease the segment gap current index, maybe. I don't know. Nah, it still teleports a bit. Yeah, I should play around with this. Yeah, and also I think the overall structure of the code is going to change a bit. I mean, all of these kind of like methods here, they aren't slow. I mean, and this logic here should of course be split out, but even with the logic, okay. And if I disable the actual debug validation layer, we will probably end up spending a lot of our frame time waiting for the GPU here. Yeah. So we won't notice any of the CPU side stuff. Let's see, let's try screenshotting our wait GPU 0.33 milliseconds. Let's just try cramming a lot of stuff in here. Maybe even some bloom stuff here. Let me see. Okay. And let's see. So the comparison here. We don't even wait as long. Yeah, the backend calls still take most of our frame time here. Yeah, we do need to draw more objects. Our bloom pass doesn't require anything additionally on the. I wonder what the backend calls. Is it including the wait? I think so. And the game logic itself is like literally nothing. But sometimes we end up with a bit bigger backend calls, right? I don't know. Maybe it's when it's swapping between the OBS and the GPU. Yeah, so it doesn't really increase our actual frame time that much. So yeah, it's probably just spinning up stuff, waiting for stuff. Um, yeah, it doesn't really affect anything, it seems. Anyway, this code is somewhat buggy, and I'm not gonna fix it right now. I gotta do some stuff here around the apartment. But at least things got up and running. We definitely have a, you know, set point for creating builds, consuming stuff. And that's pretty awesome. It means that we can also create conveyor belts that kind of like link to each other. Merging and splitting belts is a whole other thing. But yeah. We should also, I think, maybe add something like the iron extractor, pushing to whatever belt it has here. So this should probably create a segment where this is supposed to be a segment and this is going to be a segment, and we will move items along those segments. How to handle those dependency changes is something else though. Minecraft? Why do you say that? Okay. ring buffer stuff works. Although this doesn't get reset. I guess I removed it, did I? I end up in a state where this, for some reason, I mean, it it's set to 0 whenever the thing gets consumed, I think. Okay. Gap index, current gap index. And then it sets it to 0. Oh, it's whenever the exit gap, I guess. Yeah, so it's the exit gap that sets it to this garbage value here. I mean, why doesn't it delete that one? Yeah, it's definitely messing around here. There's some error somewhere in this. Uh, 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 uh. Yeah, it should. Like, it just popped them correctly, but then well, the right head itself. Okay. I guess it's the right head and the read head that is not synchronized. Maybe in this series of events. No, it's because it's actually like this. Isn't it? I don't know. No, it's not. This gets out of whack though. Um, so whenever we move this up, uh, yeah, it shouldn't create one afterwards. Maybe it's the creation algorithm. Oh yeah, I think so. I think so. Okay, so if the right head is actually, well, so when I create two objects here, the right head should be here at 3, which it is. But then it does something very weird, where the right head kind of like retracts or something. uh, oh, it's because, is it? No. So we're allowed to add items here. And we increase the right head. Let's just debug values, gap count, debug 1 here. Debug 2. Let's see, item right head, read head, item right head, item read head, even though it's wrong, it's item tail is actually the correct one. Okay. Why does it the right head reset? Oh, I think I made a mistake here. Yeah. 1. Ha, we reset it. This is still the same. Yeah, we still have that teleporting thing, but it at least the information here. Gap count. I also think that this code here should remove the gap current index here as well. Okay. And we immediately see these end up being the same, so that's fine. Okay. So I'll look into the teleporting bug later on. Yeah. So that's basically it. Conveyors almost. Conveyor coupling. All right. That's pretty great. Okay. That's pretty cool. And this has produced 5 recipes. We could try increasing the recipe time like to something absurd. And this should actually be 59. But let's do 350, or rather something like this. Yeah, it's definitely not. Yeah, it ends up teleporting a bit whenever it consumes. So I need some kind of like way to actually calculate the new stuff. And maybe segment entry gap here minus, I don't know. Let's see what happens. Yeah, we still teleport. Yeah, it's definitely the logic here. Some of this stuff here is not correct. It doesn't handle the cases correctly. Anyway, I made some nice progress. The machines can now check whether a end of a belt is nearby, and it can actually collect the items and store them inside its input. And the ring buffers themselves are just working absolutely perfectly. So that's it for this part. Next is the actual bug fixes and then some streamlining of the code. In order to actually make an iron extractor that kind of like outputs this stuff here. We would have to do some dependency chains in terms of belt segments. Yeah, I'll have to figure out how to do dependency chains efficiently. Yeah, so we're almost at a place where I can remove the underlying vectors and instead just use static arrays. And this keeps on chugging. Yeah. So this should output, of course, some resources as well, because it has 20,000 iron right now. It's mining very fast, 1,000 per tick. This is actually wrong in terms of title, but who cares? Okay, I'm gonna do a break. Maybe I'll jump back on the stream later. Thanks to everyone who tuned in. Hopefully I'll be seeing you guys around. If you found any of this helpful, entertaining, or just inspirational, feel free to support the channel by commenting, liking, or subscribing, or even checking out ways to do it in the description down below. Alright, please take care everyone. Bye bye.